All right, should be shared, yeah? All right, hey everyone, I'm Joe Flasher. I'm the Open Geospatial Data Lead at AWS. So thank you very much for having me here. I'm always excited to talk about open data, but also my wife and I recently had our first child, so I haven't really been up past 8 p.m. for some time, so it's good to have an excuse to try and do that again. So I want to talk to you a little bit. I was sort of given the prompt of talking about open data sets in AI, and specifically around mining, obviously. And I wanted to talk to you about some of our perspective on this. I'll explain a little bit more sort of what we do with open data at AWS. And I'm not going to be talking about anything with mining specifically. I do have a specific AI example, but more broadly, I'm going to be talking about sharing open data generally and sort of the trends that we're seeing and how we work with that at AWS. So broadly, I'm going to talk a little bit about sharing data in the cloud. We're obviously biased, but we think it's a very good way to do it. I'm also going to talk to you a little bit about how we expose open data for people to find. And then I'll talk a little bit about data at work. And this is sort of a nice little catchphrase that we use to sort of show off how people are actually using data. I used to do sort of a thing when I would be speaking in person and I could actually see an audience. I would sort of like ask people like, what does data want, right? And I'll sort of shortcut to the punchline here, but data wants to be used. What's the point of making data available? What's the point of collecting data if you're not trying to have it be used in some fashion? So we sort of say data at work because we're trying to get across the point that the whole purpose of making this data available is so that people can actually use it for some purpose. So oftentimes that's an implicit assumption, and we try to make an explicit assumption and show you how different customers of ours are doing that. So I have an example that I'll share at the end that I think will be pretty relevant to this group, hopefully. So just broadly, if we talk about sharing data in the cloud, and I'll just sort of take a step back and say, like when we talk about open data, we broadly mean data that can be used for any purpose without any restrictions. We do work with data sets that don't exactly fall within this definition. And you can think of sort of genomics data in this case, where the data might be freely available, but it's not necessarily available to anyone. You may have to prove that you have a reason to access the data. Like if you're going to see people's like genomes tied to an actual person. But we sort of classify them all under the same umbrella and sort of set this aside from sort of proprietary data or commercial data that you would pay for. And again, it's just what my team focuses on. My team focuses on open data. You'll see that very clearly in a little bit here. But what I'm talking about here is actually just best practices for sharing data full stop. Whether you're doing that publicly or whether you're just doing that sort of within your own institution, the sort of best practices still apply. We just use open data because it's easier to work with when sort of gaining these best practices. So I think it's fair to ask, why do we care about open data? And quite simply, we care about open data because our customers care about open data. We have a large number of generally public sector customers that are looking to make this data available. So these are oftentimes government agencies, nonprofit organizations, research institutes that are sort of collecting this data and have a mandate to make it publicly available. And then we have a lot of customers who are looking to make use of that data for various purposes. Here we use Maxar, which some of you might know. They're a large geospatial data company focusing on collecting satellite imagery, very high resolution satellite imagery. And I believe I sort of said it as an aside in the beginning, but I focus on geospatial data. So a lot of the examples that I'll use here are going to be geospatial relevant. So I think if you've been working with data of any scale for a while now, this is not going to come as any surprise, but we see data growing larger and larger. We see data coming in from new sources all the time. There's a whole bunch of different types of data. There's a large audience looking to use that data. And people want to be able to use many different applications to access the data. I think previously we might have seen sort of proprietary data formats for proprietary data programs, like actual software programs to access the data. And I think that model is sort of going out of style. Sorry, my cat is trying to jump up on the laptop here. So I think what we've seen is that siloed approaches don't work anymore, and we've seen customers moving to a different paradigm. And at the risk of sort of throwing out a very buzzwordy type of thing, I think we see that cloud data lakes are the future, or data lakes built in the cloud. It really allows you to eliminate data silos. You can have a single store of the data, so you sort of have a single store of truth, but you can have any application come and work on top of that data. If you choose the right data store, the right object store, you can have a whole host of applications. You don't need to worry about duplicating that data in a whole lot of places. And this is essentially what we do with the Open Data Program. I'll speak about it a little bit more in a bit, but I want you to sort of keep in mind that what we're doing is making data available for groups to use at scale. But I will say that a lot of times when you talk to people about a data lake, they will say, just put the data there and you can figure it out later, right? And that's a bit unfair. And the reason why I'm bringing this up to you is because I assume that what you're thinking of is how to either work with data sets that are already available somewhere, or amongst yourselves, how you can go about making this data available for others to use, even if it's just you all internally. You can just stick data somewhere and sort of figure it out later. But if you put in some work ahead of time, you can figure out a very good way to make the data available, right? Like the fact that you can put it all somewhere and store it all for relatively cheap doesn't mean that you're making good decisions. So what we're trying to help groups do is figure out the best decisions to make when they're making the data available, so that they can reduce a lot of work that's done by every group that comes downstream. Just to give you a really brief example of this from the geospatial context, one of the first large geospatial data sets we made available was a satellite imagery product called Landsat from our US Geological Survey. And the way that the data traditionally came from was it was all sort of in an archive format. So it was all put in a tarball. And if people wanted to access any of the data, they would have to download the whole tarball, which was like 1.5 gigs, and they would have to unarchive it, even if they only wanted like a few kilobytes of data. So we talked to customers and they said, hey, this is a big pain. I'm wasting a lot of time downloading this data. And so when we made that data available in the cloud, the very first thing we did, was just unarchive the data. This is obviously an incredibly simple thing to do. There's not a lot of science behind this. We just basically unarchive the data. But what we did there was eliminate work that every customer was doing to have to use the data set. And so we have a name for this across Amazon. It's called undifferentiated heavy lifting. If we can seek to remove this from our customers' lives, we are obviously adding value, right? So if we see tasks that customers are doing over and over and over again, we seek to remove that from them so they can stop doing that and they can get on doing the piece that they really want to do. So I would sort of encourage you to think about this whenever you're looking to make data available, is figure out what patterns everyone is having to do on top of that data. Sometimes it might be as easy as unzipping something. Sometimes it might be like turning into a different format or something like that, right? But if you know that everyone has to do that step for them once, and you're going to make everyone's life easier. So there's this thing that comes along when you sort of think of the data lake model, and it's this flipped data flow, right? And so I want to sort of be explicit about what this means, because I think it's important when you're looking to make data sets available. Again, if you want the data sets to be used, especially if they start to become large data sets, you don't want to force groups to have to download that data, right? If you're forcing groups to download that data and use them on the local resources, you're actually constraining the types of questions that they can ask. Sort of to paraphrase something that the research scientist said to me one time, was it's that like scientists will only ask the questions that they know they can answer if they're limited in the resources they can use, right? So if they have to sort of be able to store a large amount of data locally, or if they have to be able to take the time to download all that data, or have the processing power locally to analyze the data at scale, then they will only ask the questions that they know how to answer. They know that they will be able to find an answer in the limited amount of data or processing that they have access to locally. But if you let people use the data sort of in place in the cloud, it sort of democratizes access to everything, right? Because you're not limiting people by what they have access to locally, either storage or processing power. So sort of to really drive this home, like if you think about it, if you had a petabyte of data that you're trying to access, right, which is a large amount of data, not everyone's going to need to access a petabyte of data, but it's becoming increasingly more common depending on what types of data sets that you're working on and what domains, that is not like a crazy number, right? But if you were trying to access and download a petabyte of data across a good data connection, that would take you about 5 years. We just recently had a customer that accessed or analyzed a petabyte of data in about an hour and a half, right? And so that includes the time that it took them to access that data and then to actually process it and do their analysis. You can obviously ask a lot more questions if you can do that in an hour and a half than if you have to wait for a year just to get access to the data. And that's assuming that you even have a place locally to put a petabyte of data or processing power to analyze that locally. So just to sort of be very explicit about this, the flipped data flow here is that when you make the data available in smart ways in a location, like in an object store like S3, which is the one that we have at AWS, you can run a whole bunch of different tools on top of that data, right? And I don't want to sort of turn this into an AWS infomercial, but we are always creating new services to work with that data. So you can use your own tools, right? Like I'm sure like any other domain, mining has a whole bunch of tools that you've been working with forever. But there are also a lot of other tools that are being built that you probably don't even know exist yet that might be of help for you and what you're trying to do. And we continue to build those and you get access to all of those, being able to work on top of your data if you're working with that data in the cloud. This is obviously not true if you're bringing it down locally. You're sort of tied to the traditional tools that you've always used. So this obviously has an incredibly democratizing access or democratizing effect on the data because you're removing barriers to people trying to access the data. The other thing that we've seen, and this one's kind of crazy, this is actually coming from the meteorological field, as we saw, and I'm thinking of one specific instance when we were talking to a customer, they knew that they were working with an out-of-date copy of the data, but they didn't want to take the time to download it again, right? And so they were going to have to publish a peer-reviewed paper knowing that they were working on top of an out-of-date copy of the data, simply because they didn't want to take the time to bring all the data was located on an FTP server to bring it all down to their local computers to be able to run their models again. That obviously is not a situation that anyone wants to be in, right? Like if you're putting the time into making these data sets, keeping them up and trying to gather valuable data for groups to use, you want them to be able to use the latest and greatest that you're making available. So I want to talk a little bit here about how we go about exposing this data to customers. Because I think it's probably useful as an example in its simplicity, right? So we have this thing called the Registry of Open Data on AWS. You can see the URL down there. And if you go there, you will see a list. I forget what the number is now, but it's probably around 150, 160 different data sets that are made publicly available in AWS. And we work with a whole bunch of customers to make this happen. And so there are a whole lot of different ways that you can sort of expose data to users. I think what we very commonly see is sort of data portals, which users can click around and then they download something, but you're sort of back down to the model of forcing users to download something. We sort of wanted to take a bit of a simpler approach because we're not really trying to create a data portal. What we're really trying to create is a data catalog. And it's sort of a fine distinction that I don't know has like a very well-defined sort of definition behind it. But for us, all we're trying to do is allow people to find where they can access certain types of data. So here you can see like we have tags that are attached to different data sets. And this one's showing off satellite imagery. Again, I mentioned I focus on geospatial, but you can see the different types of data sets that we make, or you can see the different data sets that we make available. But then when you sort of get into them, what you're left with at the end of the day is data sitting in an object store. And I don't really want to go too much into what an object store is. I know there are other people from AWS here. I hope none of them are sort of on our service teams or our engineers, because they would kill me if I said this, but you can think of an object store as a sort of a file system or a hard drive in the sky that you can keep filling up with data, right? Like this is a sort of a logical way to think of it. You can keep putting data into it and access it at a very high rate. And we make the data publicly available so that anyone can come and use this data. Obviously, it is not public by default. If you put data in there, only you can access it. But our program works to make the data openly available. So anyone can access the data that's sitting in these S3 buckets. So, but we sort of expose this at a very low level. And so this is that what you see here is an example of using one of the command line tools that we have. That's just getting you access to the underlying files. And that is pretty much the level at which we expose this data. This is a very specific choice that we've made. You might be asking yourself like, hey, why don't they build all these other tools on top of the data to expose it? That's a fair question, but that's not sort of the level that we play at, right? I generally like to think of us as an infrastructure company. At least that's how we think of it on the team. And we're really exposing data as infrastructure here, right? The public data set program, sort of the program that I'm speaking about now, actually goes back to the initial days of when we made sort of our service that exposes virtual machines for folks to use, because they realized that it was one thing to have a whole lot of processing power at users' fingertips, but if you didn't have any large amounts of data to show off what you could do with the processing power, it wasn't very useful. It wasn't very easy to show people what they could do. So so I think of this as data as infrastructure. Like you have a whole lot of processing power, but you also need data to work with to actually do something with that processing power. And so we sort of expose the underlying data at a pretty raw level, and then we make it available in this way so that anyone else can come and build the sort of interfaces that they want to on top of it. And I think that's another thing that I would sort of like to get across to you, which is it's unlikely that you will know the best way to make data available from the get-go. If there even is a best way to make data available, right? There are many different good ways to make data available. There probably isn't one single best way. There are also a number of bad ways to make data available. But if you get your data available in one of the good ways, then you can let other people come and build other interfaces on top of that to meet the specific demands of various communities. So I don't have it in here, but we sort of have a chart. It's sort of very easy to describe, which is it's almost like a bell curve. Like when you start doing some amount of work to make data available, there's an increase in the usability to people, right? Obviously, the example I gave before, just putting up a lot of data in sort of an archival format. Once we sort of unarchived that, we started going up the curve of how usable it was to users. And this is sort of where it comes into like, it's a bit of a paradox is, or counterintuitive is you can put in more work and then you're actually decreasing the overall usefulness for a community, right? So if you start to do more processing on the data, or if you start to make very purpose-driven APIs for people to access the data, you're probably increasing usefulness for a subset of your users, but you're decreasing usefulness for your community overall. So what we try to figure out and help customers figure out is what is the right level of abstraction to make the data available so people can come and build whatever they want to on top of it. We also think that usage examples and groups seeing usage examples and how to use the data is critically important. So if you look at the Registry of Open Data, for all the data sets, you will see tutorials, tools and applications, publications that are using the different data sets so that anyone can come here and not only do they have access to data, right? And that's great. They also have access to processing on our platform, but they can also see how other users are making use of this data in a variety of different ways. Because we think that being able to see these sorts of examples of how other people are using the data in practice is critically important, right? So I guess if I'm here to impart any wisdom, tutorials, right? Tutorials, good documentation. It's critical to other people being able to use any of the data that you put all that time into collecting. So, and I mean, this is very specific to our use case, but all of this is open source. So if anyone's looking to add a new data set mention or add tutorials or anything like that, we make it very easy for them to be able to do so. So there isn't a huge gating process for them to go through. And this is basically a way that we try to make it as easy as possible to sort of get more of this information out there in the world. I do want to sort of mention here, if it sounds overly simplistic, what I just described, it is, and that's by design, right? We work with customers to make data openly available in our object store, and that's honestly pretty much it. It's got a very open policy. It says anyone can get access to the data. We don't do anything beyond that. And again, like I said, it's because we wanted the least amount of friction for users to be able to use that data. There are a lot of cases in which that doesn't work, right? I kind of mentioned the genomics example earlier. If you're looking to only allow access to certain groups, like certain groups are within your consortium, or certain other companies or any other parties. If you're looking to sort of monetize any of this data for any purpose, we do have other ways that you can do this. And here I'm pointing to AWS Data Exchange. So this is a mechanism where you can actually sell data or have data subscribers, and you can have them agree to certain licenses and everything. And so conceptually, it works a bit similar to a lot of the things that I've talked about, and the best practices are still the same, but it allows you much finer grain control over who's getting access to any of your data, if that's important for your use case. So I wanted to sort of close out here by giving you an example of data at work, and I wanted to pull one very AI-specific example. And I'll start off with this quote here from Ryan. And so I'm going to talk about SpaceNet. And so I'll talk a little bit more about what SpaceNet is. But SpaceNet is essentially trying to reproduce for the geospatial community what ImageNet did for the broad computer vision community, right? Which is publicly make available high quality labeled training data to push the boundaries of machine learning in a geospatial context. So SpaceNet is a collaboration of a number of different partners. There are industry groups here, governments represented. There's a number of commercial entities, including sort of large enterprise ones, as well as smaller startup ones. A couple of these groups are satellite data providers. And so it's a broad sort of coalition of a number of different partners. And it's basically dedicated to accelerating the open source work around geospatial and machine learning. So I want to sort of call out the 4 pillars of SpaceNet because I think it's a very good example of how to incentivize and mobilize a community, not only to make high quality data within a certain domain available, but to get others to make use of that data, but make use of that data in a way that enriches the whole community around that data set. So I think the very first thing is SpaceNet provides a very unique data set, right? If they were just doing sort of the same thing that's already out there in 100 different ways, I don't think they would have seen as much traction, but they're providing a very unique data set in 2 ways. One is sort of the underlying data, which is high resolution satellite imagery, or in sort of a very recent example, synthetic aperture radar data. They're providing, like, that data is very hard to come by, right? Outside of commercial channels. So they're providing a very unique data set there, but also they have very high quality standards when it comes to how that data is labeled. And so people know that if they're using that labeled training data, that they're sort of accessing a very high quality product, right? So it makes people more willing to use it for their own purposes. It's also got a very broad license, so that it's not limited to only research use or anything like that, right? So it's sort of got a very permissive license. It also runs competitions, and the goal of the competition is to get competitors to create algorithms that sort of push forward the field around certain topics. One of my favorites was a challenge, I think that happened 2 challenges ago, was where they looked at off-nadir imagery. So I think I should still be on video, so I think you can see my hands. But if you're familiar with satellite imagery, if you're looking straight down, that's like on nadir. And then as the satellite starts to look at a more oblique angle, that's called off nadir. And so they wanted to figure out how well could you do building detection on off nadir imagery. So if the image was further and further apart, like how well would your algorithms for detecting building footprints work? The reason why this is important is, well, a number of reasons, but it's very important in, say, a disaster response context, because as you have more satellites that are in the air, you have more sort of small sats that might be able to get you oblique imagery more quickly, off nadir imagery more quickly. If you have to wait until the satellite is directly overhead, that's obviously going to take longer. And if it's a disaster response scenario where you're trying to figure out what buildings have been damaged, say, you want to be able to get to that data as quickly as possible. So they have a number of sort of competitions that push very specific focus areas like that, right? They're sort of defined challenges. The other great thing about SpaceNet is they provide actual cash prizes. And they've been very successful in gaining submissions. So the number I have here is from 5 competitions, and that's about 1,350 submissions. They actually just finished up their 6th competition, And what's really cool is the sixth competition saw more submissions than all of the previous five combined, which obviously means that there's a whole lot of momentum building for SpaceNet. The winning algorithms are open sourced, and they do a lot of sort of detailed analysis of the data sets and provide all of that back to the community at large. And I think this is sort of some of the SpaceNet findings for what they were going for. And I sort of mentioned this already. They're looking for quality, availability, accessibility of the data. They're not forcing people to sort of store this data themselves. Once they make the data available, it's there long term. I think one of the things that they noticed early on, especially in sort of challenge or competition driven data sets, is that often after the challenge or competition is over, the data set goes away. And they're also trying to use modern, cloud-friendly, interoperable data formats to sort of make it as natively accessible by a whole bunch of tools. So I want to stop there, and I wanted to leave some time for questions. I'm happy to sort of take any questions. And one of the things that I wanted to make sure to say was, if you all are thinking about data sets that you want to make available, how you want to make those data sets available, please reach out to me. There are a number of AWS folks that are here on the call, but also that I think are with you on a sort of more ongoing basis. They'll know how to reach me, but please, our program works with groups like yourselves to figure out how best to make open data sets publicly available. And I'd be more than happy to sort of help you think through that. So I will stop there. Thank you.
Thank you, Joe, and thanks for that offer at the end. Greatly appreciated, and I'm sure we'll take you up on it. So do we have any questions?
Hi, Joe. It's Mark here from Caltire. Thank you for that. That was very interesting. I've got a couple of quick questions. One, my company is 100% Microsoft. Sorry about that, but does everything you say, all our stuff is in Azure? Can we interact with Amazon products easily and simply? And secondly, what you said at the end about cloud-friendly data, could you sort of enlarge a bit what cloud-friendly is?
Yep. Yeah. So to the first part of your question, this is largely going to depend on the tools you're trying to use, and not necessarily the cloud platform you're running on. There's nothing that prevents, well, to my knowledge, there's nothing that prevents AWS services from being reached from Azure, right? Like I'm pretty confident in that statement, right? And so a lot of the tools that you use, one of the benefit of sort of being in the position that we are, and with the sort of the object store that I mentioned, S3 being so widely supported, is a lot of the tools that you use will already support that as an object store. So yes, it's going to depend on your tooling, but you can likely run that tooling in Azure and pull the data from S3 for sure. Because at the end of the day, when the data is publicly available, it's just basically like a web accessible object store, and you can take advantage of that. The cloud optimization piece, it's going to depend on the different data formats. And one of the purposes that we sort of have our program for is to figure out in different domains and for different sort of file formats, what does cloud optimized mean? I'm most familiar with geospatial, so I'll just speak to the satellite imagery piece. There's been sort of, if you're working with raster data, which a lot of satellite imagery is, this basically just means like it's pixel by pixel data, right? So row, column, and you have like a value. If you're working with raster data, there's sort of been, I'd say in the last 3 to 4 years, the standardization on something called cloud optimized geotiff. Geotiff has been around forever. Cloud optimized geotiff is still standard geotiff. It's just everyone agrees to do like 4 things that were already in the spec. And so the sort of the most salient points of that, going into too much technical detail, is that you can access the bytes that you want with the minimal amount of bytes that you don't want, right? And so I mentioned sort of the worst case example where you're sort of putting everything into a tarball and you're forcing everyone to download like 1.5 gigs and they just want 10 kilobytes, right? Because you can imagine if you're a farmer, if you're a miner and you're just trying to do like find a mine or something, right? Or to do something around a mine. I'm not a mining person. I don't know. I'm literally waving my hands, which I hope you all can see right now. Like if you just want to circle your mine, you don't need a whole satellite image. You only want the little bit within your bounding box. And so what cloud optimized geotiff does, it's just basically a reorganization of the bytes within the file. And you can do, you can access just the amount of data that you want with the minimal amount of data you don't want. Because remember, you're doing like network requests for this data. And so you don't want to have to transfer extra data around because it adds latency. So in general, That's what we call a cloud optimized format. What that means in any given context is going to be different.
Thank you. We have a question from Daniel Koffler.
Yeah, hi, Joe. Thank you, Heather. That was a great presentation. We've been using, just to validate your point on the AWS, Azure interoperability. We've definitely pulled Nextrad data sets from S3 into Azure Object Storage and other data repositories before. So definitely possible. So, you described the undifferentiated heavy lifting and the bell curve of usability, which, I think is great and accurate. But in my experience working with some of the open data registry data sets, there's still quite a bit of space between, I think, the format that the data is provided in and, maximizing the usability of it. And so while the open data registry has been around for quite a long time, some of the newer AWS services like SageMaker are, are newer. And so, just some of the things we've struggled with that I definitely think fall into that undifferentiated heavy lifting category are things like one-hot encoding of data in the data sets and just making the data more usable for things like machine learning algorithms. And I'm wondering if, going forward, you guys are looking at starting to do some of that pre-processing of the data before making it available, and whether you're looking at going backwards into the catalog and doing that for existing data sets at all.
Yeah, so it's a good question. So the answer is broadly, well, the answer is both yes and no. So your point is very well taken that not all of the data sets are as cloud optimized or cloud friendly as they could be. And I think largely that's because, and I didn't really get into this piece, but the data sets are all done in collaboration with customers. So there are, I think at this point, 3 data sets that Amazon owns, like they're Amazon data sets on the registry of open data. All the other data sets that are up there are owned and managed by customers. So there's no, we did this very explicitly. We don't want an Amazon stamp on any of these data, right? Because like, I think somebody reasonably, if they looked at Nextrad and saw like a little AWS logo, they would be like, what does AWS know about Nextrad? And the answer is very little, right? We're not the subject matter experts. So we work with NOAA to put up the Nextrad data. This is a strength, but also we don't have the same ability to sort of get everyone to do the same level of optimization on all the data. And we don't want perfect to get in the way of sort of good enough to be very helpful for customers. So I think broadly to answer your question, we want to know where we can do better. And we look to the community to do this, right? Like in a lot of ways, my team is a consensus finder and builder. Where we can find a number of customers that want a certain thing, we can move on making that data available, right? And so I would definitely, please reach out to me. I'm just jflasher@amazon.com, or reach out to the other AWS folks here that can get me the message. But yes, it is of interest to us, and we are willing to go back and figure out ways to make data that's been around longer and may not be cloud optimized into optimized formats. And our hope here, and we have a very great success story of this, is our hope here is that we can eventually take these learnings and take them back to the source agencies. And an example of this is actually USGS. So I mentioned that Landsat data. That data to date actually is still provided by a satellite startup called Planet Labs. They're the ones that manage that data. But we were able to take what we did there, take that cloud optimized format, show it to USGS and be like, hey, look, this is what your customers are doing with the data in this format. And USGS, to their credit, said, awesome, this is what we want to do. And so USGS is actually moving all of their data onto AWS, the whole Landsat archive, and they're going to be making it available in this cloud optimized format, right? So we have examples of this working in practice, but we need to oftentimes we need to show what can be done when we do it this way. And we're always looking for groups to work with to make that happen.
Are there any other questions?
Yeah, I've just got a very quick one, Joe. Thanks very much for the presentation. I really enjoyed it. Just very briefly, what's the kind of process? I've got a data set. I've got one here. I want to put it up on AWS. what's the general process? I know it'll be different for different, different organizations and data sets, but in general, like how do I go about it? How do I upload it? Is it my responsibility, your responsibility? Are you gatekeepers? What documentation do you expect?
Yep. Yeah. So I actually just dropped something in the chat there. So the way to start with an application is to like, if you know how to get in touch with us, you can just reach out to us and we can sort of have an informal conversation. You can also we will always ask you to fill out this application, and you can see from the application the sort of by the questions we're asking, like what we're looking for, right? And so basically we want to know, like, okay, how big is the data, right? And one thing that I haven't said yet, because I didn't talk too much about the public data set program, is that there is sort of a back and forth here, right? We expect something from the group putting the data there, but then we also give something. And so what we give is free storage and egress for the data that we're agreeing to make available through the program. But what we ask for is a commitment from the customer to make sure that the data stays there, make sure that it's well documented, that it's updated, and that they do work to make it available in a cloud optimized format, and that they're willing to sort of show others how this data can be used in the cloud. And so that's the sort of, sometimes people think of it as like a free storage program. And I don't like to think of it, because we're asking the customer to do work to make it available there, right? So the sort of questions that we ask are, how big is it, first of all, right? Who is going to be using this data? Are you willing to work with us to make this data available, figure out how to best make this data available in the cloud? And are you willing to talk to people about how to use, like through a tutorial or something like that, how to use it in the cloud? If all of those, like, you can generally figure out what the answer should be, right? So if like all of those answers look good, then we're very eager to sort of bring these things on, right? And so I'd say like looking at the application is the best way to sort of go about that process. And I think there's egress of the open data is free. So yes, the public data set program pays for storage and egress of the data that we agree jointly to make available through the program.
Cheers. Thanks.